Should we deploy AI in situations where being wrong is expensive? I want to present a case for why we should and how we might approach it safely. In Australia, the consumer watchdog, the ACCC, fined EnergyAustralia 14 million Australian dollars for making misleading statements about electricity pricing. EnergyAustralia admitted it breached the Australian consumer law in communications sent over a period of 3 months in 2022 to around 566,000 consumers. The breaches involved failing to state the lowest possible electricity price and misrepresenting the estimated annual price for an average customer. In Germany, Deutsche Bank's asset management arm, DWS, was fined 25 million euros for greenwashing, making misleading statements publicly that it was a leader in environmental, social, and governance investing, and that ESG was an integral part of its DNA. Both cases show the same thing. In regulated industries, words and statements can be expensive. One wrong claim, one misplaced phrase, and the financial or reputational fallout can be huge. So should we really deploy AI in places where being wrong costs this much? Let's examine the nature of high-risk environments to help us answer this question. Industries like finance, healthcare, and energy are built on guardrails. Multiple checks, sign-offs, approvals meant to stop small errors from becoming big ones. On paper, it's safe, but in practice, it's exhausting. Professionals spend their days approving, reviewing, and rechecking, often without full attention. The problem isn't just human fatigue. It's the linguistic fragility of these scenarios. Consider the difference between likely and highly likely in a medical diagnosis. The point is, a single wrong word in a medical report, a financial disclosure, or a compliance statement can shift the meaning drastically and lead to real harm. Add to that the constantly changing regulations and evolving real-world incidents, and you have a system under cognitive siege. These environments are designed to stop human error, but their complexity often creates more of it. The cognitive load in these jobs is brutal, and now it's multiplied by generative AI. A 2024 archive study analyzed over 687,000 consumer complaints, 537,000 corporate press releases, and more than 300 million job postings. It found that after ChatGPT's release by late 2024, roughly 18% of financial complaints and 24% of corporate press releases contained LLM-assisted text. That's a tidal wave of new information. And who's actually reading and verifying it all? Researcher Salem Lalu argues that our problem isn't just the misinformation, it's the cognitive capacity. Human and institutional attention can't scale with the information environment that Gen AI has created. We're reaching information saturation. Consider spam filters. In the 90s, a human could review flagged emails. By 2010, the volume made that impossible and automation became mandatory. We've reached that same inflection point with regulatory compliance and corporate communications, where the consequences far exceed a missed newsletter. AI hasn't just increased what can be written, it's also increased what must be read and checked. At this scale, automation isn't optional, it's necessary. The danger of AI is real, but so is the danger of humans being cognitively overwhelmed. The cost of not using automation is missed signals, delayed reviews, unmanageable workloads, and it's starting to rival the cost of deploying it. To make AI failure survivable in these high-risk scenarios, we need containment architectures, systems that absorb and correct errors before they cascade. With containment, we're not seeking to lock AI down. We're seeking to build resilience through structure. Think of it as a counterweight system. Aircraft have multiple redundant systems, and pilots have instruments that show when those systems disagree. Observable disagreement becomes the model. When two AI systems trained differently reach different conclusions about a claim, that disagreement functions as our early warning system. The same technology that scales the generation of written text can also scale the verification of that text. Fact-checking is a good example. The BrainCube checked linked in the description can already do fact-checking across long PDF documents, isolating your claims using agentic search to find corroborating sources across the public internet. AI verifying AI, and it's linked in the description to this video, so check it out. But that raises an old question. Who checks the checker? We don't need infinite checkers. We need adversarial pairing. One system optimized to generate, another to critique, with humans remaining the final decision point. Think of it like restaurant food safety. The chef prepares the food, The health inspector verifies safety standards, and diners make the final choice to eat. We don't send a second inspector to verify the first inspector. That would be absurd. Instead, we monitor inspector performance through complaint rates, audit sampling, and outcome tracking. The same applies here. The verification AI doesn't need another AI to verify it. It needs performance monitoring. Data scientists sample its outputs, track accuracy trends, and run controlled experiments to ensure it catches what it should. AI can assist this monitoring work, calculating statistics, flagging anomalies, curating test data sets, but humans define the standards and interpret the results. We already know how to monitor stochastic systems through sampling, testing, and tracking drift. AI can be continuously evaluated in production, just like engineers monitor a power grid. In practice, that means fact checkers, audit agents working alongside humans, not replacing them, preserving judgment under cognitive pressure. Containment rests on 3 pillars. First is explainability. Every AI action must trace back to a source or a rationale. Human oversight. People remain the final arbiters in high-cost decisions. And finally, feedback loops. Every failure becomes structured training data. Even with containment, another question looms. Who is responsible when AI gets it wrong? Right now, accountability is shared but vague, split between model builders, software vendors, and deployers. The EU AI Act, which came into force on the 1st of August 2024, starts to change that. It creates a risk-based framework with explicit duties for all parties: providers, developers, importers, and distributors. For high-risk systems in areas like healthcare, finance, or employment, it mandates documented risk management across the system's lifecycle, strict data governance for training and testing datasets, detailed technical documentation and record keeping, defined human oversight mechanisms, and ongoing monitoring to catch issues early. This marks a shift from vague principles to traceable accountability. Providers are responsible for how systems are built. Deployers are responsible for how they're used. Containment makes AI failure survivable. Accountability makes it answerable. So when we look at the path forward, we shouldn't think about perfection. We should think more about balance. We don't need to stuff the AI genie back into the bottle. We need to counterbalance it. The same intelligence that creates risk can also contain it if we design it to operate in opposition, not isolation. AI can moderate AI. It can run live fact checks, verify outputs, and flag anomalies, all at a scale no human team could ever sustain. The goal isn't to replace human oversight, but to amplify it, building systems that absorb cognitive loads so humans can focus on judgment, not triage. When treated as a meta agent, AI becomes something we can monitor through established statistical methods and performance data. Monitoring AI systems works best when each AI system or agent has a single well-defined task, like fact-checking. It's far more scalable to monitor one specialized system that verifies human and AI outputs than to expand human review teams endlessly to keep pace with the information search. As generative systems flood the world with text and data, resisting AI altogether isn't a realistic option. Cognitive overload has already arrived. The sustainable way forward is to use automation to manage automation, to build a self-correcting ecosystem where intelligent systems help keep each other and us in check.